So in this video, let's talk about the double angle formula, which is the most important and the often used identity along with the Pythagorean identity. And in this video, we are mainly going to talk about where the double angle formula was originated from and also why it is called the double angle formula. And to think about it, just like I mentioned in a previous video where I explained the sum and difference identity for the sine, cosine, and tangent, we need to review what the sum and difference identity was, because the double angle formula is originated from the sum and difference identity. This is what the sum and difference identity is, just like I wrote down right now. And for the sum and difference identities, the main purpose of using it is to define the trig values such as the sine, cosine, and tangent of the unknown angle or the angle measurements we cannot express easily. And we used the three special angles, which are pi over 6 radian, 30 degrees, pi over 4 radian, 45 degrees, and pi over 3 radian as 60 degrees. And from now on, while I'm reviewing the sum and difference identities, I will go a little bit faster because this is kind of a review what we did in a sum and difference identities. So firstly, if you review what the sum identity for the sine is, so the reason why it's called the sum is because in order to find the sine of an angle we cannot express easily on the unit circle, we split up with the two special angles, alpha and the beta. And again, the alpha and the beta are two of those special angles among these three of them, among pi over 6 radian, pi over 4 radian, as well as pi over 3 radian. So if you add those alpha and beta, then the sine formula for this sum identity is going to be the sine of the main angle, the first angle alpha, times the cosine of the second angle beta, plus the cosine of the first angle alpha, times the sine of the second angle beta. And this is the sum identities, where if it's a plus between the two special angles, then the two expressions, just like I explained in our previous videos, will be connected with a positive sign. So let's go to the second one, which is the difference identities. For difference identities, we form a sine of the alpha minus beta, and again, the alpha and beta are one of the angles from the pi over 6, pi over 4, and pi over 3 radians. And the reason why it's called the difference identities is because in order to form an angle measurement, we subtract two special angles. So when it is a negative sign, then the formula will be the sine of the alpha times the cosine of the beta, which is the exactly equivalent statement with the sine of alpha plus beta, just like I explained in our previous videos. But instead of plus, it will be negative or minus cosine of alpha times the sine of the beta. And this is the difference identity for the sine. And again, for the cosine is similar with the sine, except when we're adding the two special angles to form an angle measurements, then the formula will be the cosine of the first angle times the cosine of the second angle minus the sine of the alpha, the first angle, times the sine of the second angle beta. Unlike the sine, when it is a sum identity for the cosine, the two expressions will be connected as a negative sign. And this is what we call the sum identity for the cosine. And I'll go a little bit faster right now, and if you're not familiar with this concept about the sum and difference identities for sine, cosine, and tangent, you need to go back to my previous video about the sum and difference identities to think about the double angle formula. So when it is a cosine of alpha minus beta, and the cosine of alpha minus beta is we're trying to define the cosine of an angle where we can notate it using the two special angles, alpha and beta. And unlike the sine, when it is a difference identities for the cosine, then the formula is going to be the cosine of the first angle alpha times the cosine of the second angle minus, and the minus will turn into plus as it gets the cosine of alpha minus beta in a difference identities plus the sine of alpha times the sine of the beta. And this is the cosine sum and difference identities. So for the tangent, when we're thinking of the tangent, it is a ratio between the sine and the cosine. So we notate it in terms of the fractions. When we're doing alpha plus beta, where we add two special angles, that is the sum identity for the tangent. Then the formula will be the tangent of the first angle alpha plus the tangent of the second angle beta, all of that over 1 minus the tangent alpha times the tangent of beta. Secondly, when we're thinking of this difference identity for a tangent, the tangent of the alpha minus beta, then the formula will be the tangent of alpha, and this thing that was the plus will turn into the negative sign, and the thing that was the positive in the denominator, negative in the denominator, it will turn into the positive as it gets to the difference identities for tangent. So in the denominator, when it's a difference identities, that will be 1 plus the tangent of alpha times the tangent of beta. And this was the quick review for the sum and difference identities. And using this values for sine, cosine, and tangent, we'll be able to define what is the double angle formula, where we often use inside the trigonometry. So using the property that we applied for the sum and difference identities, where we use the special angles, we are going to define the double angle formula, where I wrote down a little bit right now. And one thing I need to make clear is that the double angle formula was originated from the sum identity. The sum identity, where we add those special angles to define an angle measurements on the unit circle. And the reason why it's called the double angle formula, I will explain it as we get a little bit deeper. But firstly, before we start, you need to know that the double angle formula was originated from the sum identity. And that double angle formula, we define it in this way. We see that there is sine of alpha plus beta right here, cosine of alpha plus beta, and the tangent of alpha plus beta. But when the alpha is equal to beta, that means when the two special angles have the same value, then we define it in this way. Originally, if it's the beta, then it will be sine alpha plus alpha, which is 2 alpha, cosine of 2 alpha, tangent of 2 alpha, sine of 2 beta, cosine of 2 beta, and the tangent of 2 beta. And the thing I wrote up and down will be exactly equivalent, because according to the double angle formula, the two special angles alpha and beta must be equivalent. So this is the basic statement that we need to remember for the double angle formula. So we define it in this way. So when we simply notate alpha and beta as the data, we are going to think about the sine of theta plus data when we notate the data as the alpha or beta. Also, we're going to talk about the cosine of theta plus theta and the tangent of theta and a theta plus theta when inside the sine alpha and a beta, the alpha and a beta, which are the special angles, have the same value as the theta. So eventually this will happen. Firstly, let's think about the sine of theta plus theta. When we're thinking of the sine of theta plus theta, it is going to be the sine of 2 theta, because there are 2 of those same thing. So when we think about the sine of 2 theta, that was originated from the sine of alpha plus beta, which is an addition between the two special angles. And as we extend what is the sine of alpha plus beta, we will know why we get the sine of 2 theta. But firstly, let's think about what was the sine of alpha plus beta. Well, we get the term sine of alpha times cosine of beta plus the cosine of alpha times sine beta like this. So when we think about the sine of alpha plus beta, just like we reviewed, it will be sine of the alpha times the cosine of the beta plus, because it's a sum identity, and we always need to remember that the double angle formula always works for the sum identity of sine, cosine, and tangent. So if you keep going, plus the cosine of the alpha times the sine of the beta, and this is the sum identity for this sine. But what is the statement sine of 2 theta? That is the same thing with saying sine of theta plus theta, and just like explained, that will be the case when alpha and beta are exactly equivalent. When alpha is exactly equivalent, then it will be sine of theta plus theta, when we notate the alpha and beta are exactly theta because they have the same value. Then we need to input all the alpha and beta value as theta. So it will be sine of theta. Since we know that, we replace the alpha as theta, times the cosine. Instead of beta, we also need to input the theta. And again, the reason is because the alpha and the beta have a same value as theta when we're thinking of a double angle formula. So cosine alpha, cosine theta, plus the cosine. Instead of alpha, again, we need to input the theta to show that the alpha and beta has the same value, times the sine. Instead of beta, we need to input the theta. And if you think about this, this will be the sine of theta plus theta, which is the double angle formula for sine. So if you keep moving on, we have the two terms, sine theta times cosine theta, and the cosine theta times sine theta, which are like terms. So that means we can add those two terms since we know that they are the like terms. So if we add it, we will get the 2 times the sine of theta times the cosine of theta. So therefore, from these identities where we simplify the sine of 2 theta in terms of theta plus theta, and applying our sum identities for sine, we get sine theta plus theta is 2 times sine theta times the cosine theta. And this is the double angle formula for the sine value, which is the first double angle formula we need to remember. Now let's think about the second one, using the same concept we applied. We are going to think about what is the cosine of 2 theta, which is a double angle formula for a cosine. Just like we did a sine, we always need to remember the cosine of alpha plus beta, because the sum identities made the double angle formulas. What was the cosine of alpha plus beta? Just like I explained here, it will be cosine alpha times the cosine beta minus sine of alpha times the sine of beta as the sum identity for the cosine of 2 theta. So again, it will be the cosine of alpha plus beta, which is the cosine of the first angle alpha times the cosine of the second angle beta minus the sine of the first angle alpha times the sine of the second angle beta. And this will be the sum identity for the cosine. And just like we did it for sine, we can apply that what is the cosine of 2 theta. That is the same thing with saying cosine of theta plus theta when the alpha and the beta have the same value. So when we're thinking of the cosine of cosine of theta plus theta, which is 2 theta, that is the same thing with saying every alpha, beta, alpha, and beta will be replaced as the theta. So that will be cosine of theta times the cosine of theta instead of beta. And we will have the minus sign since we know that this was originally from the cosine sum identity. Minus the sine, instead of alpha, we input the theta. And lastly, multiplied by the sine of theta instead of beta. So now when we're looking at this, we get a conclusion where the cosine of theta plus theta, which is cosine of 2 theta as a double angle formula, as cosine of theta times the cosine of theta minus the sine of the theta times the sine of the theta. If you're multiplying the same statement twice, then it will be the cosine square of theta minus the sine square theta once again. And this will be the cosine to theta. Well, so we get a conclusion where cosine to theta is cosine squared theta minus sine squared theta. But we can figure out that they have the term squared. That means we can fix this term using the Pythagorean identity just like we did in our previous videos. What was the Pythagorean identity? That shows that the sine squared theta plus the cosine squared theta is equal to positive 1. So now we have the term about the cosine squared theta and the sine squared theta. So the first version we can make is that the cosine squared theta is equal to 1 minus sine squared theta. So we can input the cosine squared theta as 1 minus sine squared theta and solve for one trig value sine squared theta. Or secondly, we can apply the sine squared theta is equal to 1 minus cosine squared theta. From this, sine squared theta plus the cosine squared theta is equal to positive 1. So first version we can do is from the cosine squared theta minus sine squared theta. So from cosine squared theta minus sine squared theta, we can input the cosine squared theta as 1 minus sine squared theta. So this will be same thing as saying instead of cosine squared theta, we input 1 minus sine squared theta. And you will have minus sine squared theta, where you have the like terms as negative sine squared theta. That means you can add up as 2 times the sine squared theta. Another version is that when you input the sine squared theta as the 1 minus cosine squared theta using the Pythagorean identity, sine squared theta plus cosine squared theta is equal to positive 1. So you will get the cosine squared theta minus, instead of sine squared theta, you can input 1 minus cosine squared theta. And if you distribute the negative sign to each terms, then you will get 2 times the cosine squared theta minus 1. So basically you have the 3 versions of cosine squared cosine of 2 theta as cosine squared theta minus sine squared theta, and you can manipulate their term using the Pythagorean identity as 1 minus 2 times sine squared theta or 2 times cosine squared theta minus 1. And I will stop explaining about the cosine of 2 theta, and I'll explain a little bit more detail why there are 3 versions of the cosine and when are they useful depending on the questions. And as we get to solve the questions from the next video, we'll be able to know why we need to use the different types of the cosine double angle formula. So after shrinking the work that we did for sine to theta and the work that we did for the cosine to theta, let's think about the tangent of 2 theta. So I removed all the mark I did for the sine and cosine and shrink it for spaces for doing the tangent of 2 theta. And again, the same concept when we're doing the tangent of 2 theta. We always need to think about what is the tangent of alpha plus beta, where alpha plus beta are the sum identities for the tangent. So what was the sum identity that we used? For tangent, that is tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta, like this. Using the formula of the sum identities for tangent, we need to know that when we're thinking of the tangent of 2 theta, which is the same thing with the tangent of theta plus theta, that creates 2 theta. That is the same thing with replacing all alpha and beta in terms of theta. So if you replace every single alpha, beta as the theta, then you will get the term like this. So you have tangent of theta plus tangent of theta over 1 minus tangent theta times tangent of theta, where tangent theta plus tangent theta are like terms and can be 2 times, not cosine, but the tangent of the angle measurements, theta. All of that over. So inside the denominator, that will be 1 minus tangent theta times tangent theta, where tangent theta times tangent theta can be replaced as 1 minus tangent square of theta. So we have the term where the tangent of 2 theta, which is tangent of theta plus theta, is 2 times tangent theta over 1 minus tangent square theta. So we define the sine of 2 theta, cosine of 2 theta, as well as tangent of 2 theta, which are the double angle formula for trigonometry. So let's review what we did here. So firstly, when we're thinking of the double angle formula, that was originated from the sum and difference identities of trig values. And so we reviewed what we did here for sine, cosine, and tangent sum and difference identities. But when we're actually thinking of the double angle formula, that only works for the sum identities. And when we're thinking of the double angle formula, there is a restriction where the alpha should be same with beta. That means it can be replaced either 2 alpha, 2 beta, 2 alpha, 2 beta, 2 alpha, and 2 beta, because that's a double angle formula for sine, cosine, as well as the tangent. So basically, we replace the alpha beta as the data, so it will be sine of data plus data, cosine of data plus data, as well as the tangent of data plus data. So if you apply the exactly same formula of the sum identities that we apply for the sum and difference identities for trigonometry, then we get this sine of 2 theta, which is a double angle formula for sine, as 2 times sine theta times the cosine theta. And also for cosine of 2 theta, we get cosine squared theta minus sine squared theta. And using the properties of the Pythagorean identity, where sine squared theta plus cosine squared theta is 1, we get firstly cosine squared theta minus sine squared theta, or 1 minus 2 times sine squared theta over 2 times cosine squared theta minus 1. And for tangent of 2 theta, that will be 2 times tangent theta over 1 minus tangent squared theta inside the denominator. This was the basic introduction to the double angle formula. And for the next video, where we are going to review the double angle formula and refresh our memories solving a question.